Good evening, students. You're able to hear me? Are you all able to hear me?
Yes, sir.
Okay. So yesterday we were discussing the concept of banking of roads.
Yes, sir.
So we were seeing circular motion actually. Yesterday the topic we were dealing with is circular motion. 1 minute. See, I'll show you a small video. See, yesterday I was telling you, right? When a car is taking a turn on a road, you're able to visualize how the friction is acting. Are you able to visualize how it is acting? See. So the red color is there, right? The red color is the vector which shows from the center to the point where the car is trying to take a turn. You're able to see that? You're able to see FC, the static friction, how it is acting across the tires?
Yes, sir.
Okay. The other red color arrow mark now they showed is the normal force. We know that N is equal to mg and the static frictional force is acting towards the center. So based on this, wait, or do I? Okay. So are you able to see the screen now?
Objectives.
So
To understand the role of friction at circular turnings and bank, centripetal force.
So when the car is trying to take a turn, you're able to see the blue color dotted lines, right? So that is the
Yes.
path in which the car is trying to take a turn. To those blue color dotted lines, if you draw a tangent, okay? So to the blue color dotted lines, if you draw a tangent, that will give you the direction of velocity of the car at that instant. So what exactly is happening?
Must act towards the center of the arc to enable the vehicle to move along it.
So when
This
the car is trying
centripetal
to take
force
a turn, you can observe that the static friction which the tires are experiencing is towards the center of the circular track. So the green color path is the circular track, and there is a road around that path on which the car is trying to take a turn. The center of the green color path will be lying at its. So this red color line is a normal force, and downward is the weight.
coefficient of static.
So yesterday we derived this. Do you guys remember? What will happen when a car is trying to take a turn on a level road? What will happen is the maximum static friction that the car can experience is equal to mv square divided by r. Accepted? This we saw
Yes, sir.
yesterday. What is Fs? Mu s into mg, because it is mu s into n, but n is nothing but mg. So mu s into mg is equal to mv square divided by r. M and m will get cancelled. V square is equal to mu s into r into g, which implies V is equal to root of mu s into r into g. I think yesterday I used capital R for the radius.
Yes, sir.
So mu s into r into g. So I hope you're able to visualize it slightly, right? Now, what will happen when the car is trying to travel on a banked road? Now,
To avoid skidding of
so
vehicles,
when the car is, see, observe what will happen
we
when the car
cannot
is trying to
always
take
rely
a
on
turn.
friction, as it depends on external factors such as rain
you see
or
what happened?
frost, which significantly
So he tried to take a turn, but he didn't succeed. What happened actually? So this also I explained yesterday.
There was not enough friction.
There is not enough static friction which can stop the vehicle from taking a turn. That is why if you observe it, again observe it clearly, okay?
moves with the velocity limiting value away
So
from the
when
center.
mu is greater than mu rg, no? So when the velocity is greater than mu rg, see what will happen to the car.
Moves with the velocity away from the center.
So this is what will happen.
Banking of roads. We cannot always rely on friction, as it depends on external factors such as rain or frost, which significantly decreases the value of static friction. To avoid skidding of vehicles at turns, the outer edge of the road
So you're
is
able to see
raised
the
up,
outer edge of the
which
road
is
is slightly
called
raised up. You're able to see what is happening to the car. When the car is trying to take a turn, it is slightly going up and it is able to take a smooth turn. If that curvature was not there, what would have happened to the car when it was trying to go with a greater speed?
Good drift, sir.
So it will skid, right? So when that should not happen, right? This is how the road is supposed to be. This is what is called as banking.
Suppose surface of the road
So
at
you're
a
able to see. So you're able to see this diagram, right?
turn makes an angle theta with the horizontal
So
surface.
when the elevation is making an angle theta with the horizontal surface, see the only drawback is I cannot write on top of it. So I cannot write on top of it, so it will be difficult for me. So what is this angle theta called as?
This results in the
What is this angle theta
Angle
called
of
as? Yesterday I
repose.
told you. Sorry?
Repose.
It's called the angle of no, it's not angle of repose. Angle of repose will come into picture only when it is trying to slide. Here our objective is the car. We don't want the car to slide down the road. It should take a safe turn. So who is making the angle theta with the horizontal? Is it the car? It is the
No.
road, right? This process of creating an inclination with the horizontal is what is called as banking of road. And this theta is called as angle of banking. Okay. So if I have to represent it diagrammatically, then see, the road is elevated like this, and this angle is theta, where theta is called as the angle of banking. And how is a car on top of it? It is like this. So car on top of it is like this. So what are all the forces acting on it? Tell me. This is a normal force. There's going to be mg, right? In this case, the important point to be understood is how is the friction acting? Okay. So in the previous case, if the road was level, okay, if the road was level, if the car is coming towards us, then when the car was trying to take a turn, what is the direction in which the friction was acting? Let's say the center of
Towards
the
the
path.
center.
So it was towards the center. This is how the friction acted, right? In the previous case, this is how the static friction was acting, right? In this case, what will happen is the static friction will act along the inclined plane. The static friction will act along the inclined plane. So if I take this to be Fs, we are going to resolve into certain components and then see. But before that, tell me one thing. Are you guys able to see what is banking of road? Are you able to visualize, or is it tough? What is happening? See. This elevation you're able to understand?
The horizontal component of normal force, n sine theta, acting towards center,
So you're able to
provided
see
that
where the center of the track is.
At O only, no, sir.
At O. The center of the track is at O. So what is the component of the normal force that is acting towards the center?
Inside.
N sine theta.
necessary centripetal
Okay.
force at the
Then
turn.
what will be the component which will be acting along y direction? Here, this pink color dotted lines are shown, right? Along the horizontal pink color line, there is n sine theta, n sine theta, which is acting towards what? Towards the center. Similarly, n cos theta is acting in the upward direction. Right. So observe. So here n sine theta is acting, and this direction will be n cos theta. Okay. So this angle theta is what is called as angle of banking. So I want you to tell me whether you are able to understand or not.
Able to understand, sir.
Okay. So how this theta actually came here is, observe, if this is theta, okay, when this is theta, suppose I draw a line like this. I'm constructing a small triangle like this. Then how much will this angle be? This will also be theta. So if this is theta, this will be 90. How much is this? Wait, I'll use another color. Okay, theta 90 minus theta, then how much will this angle be? I'm repeating it. The angle made with the horizontal,
Theta, sir.
it is again theta. When this is theta, we know that normal and this line are perpendicular to each other. What will happen? Then this will be 90 minus theta. Accepted?
Yes.
Then what will this? Then what will this angle be? That will be theta.
Theta.
Now you understood how that theta has actually come there. So I'm erasing everything. You can have a clear vision of which is theta. Okay. So when this is theta, the component which is along the angle is n cos theta. And this will be n sin theta. Okay. Now, one important concept is here we are seeing only banking of roads. So, what do you mean by banking? Elevating the road with respect to the horizontal. When you do that, that's what we call it as banking of road, right? So, in the banking of roads, the first concept that we are going to see is without friction. So, we are dealing with a banked road where there is no friction. Then, n sin theta, if it is in this direction, and n cos theta is in this direction, then who's providing the necessary centripetal force? N sin theta is providing the necessary centripetal force, which is given as mv square divided by r. Then what is n cos theta balancing?
G.
So n cos theta will be mg. That's right. So if you divide n sin theta by n cos theta, then we can write. I'll write another step. Tan theta is equal to v square divided by rg, which implies v square is equal to rg tan theta, then v should be equal to root of rg tan. So write it down. The heading is banking of road without friction. Ah.
So can you observe little bit?
Yeah. So copy this, I'll be back. Are you done?
Yes.
Okay. So this is the concept without friction. Now see what will happen with friction.
Force n sine theta
Now
acting
we are able to
towards
visualize why
center,
n sine theta I wrote it
providing
as
the
mc square by r, mb square by r. Because n sine theta is the force which is providing the necessary centripetal force.
necessary centripetal force at the turn. Friction is not taken into consideration here. Therefore, n sine theta is equal to mv square by r. The vertical component of the normal force balances the weight of the vehicle. So, n cos theta is equal to mg. From these equations, we arrive at the equation tan theta equals to v square by rg. Thus, v is equal to, in the absence of friction, for a given angle of inclination and radius of curvature, ensure that the vehicle remains rated speed of a curve
Now
does
see, the other point is not given. What will happen to the banking of road with friction? That is what we need to understand. This is a tricky concept. So this point you understood, right? This horizontal. This angle is theta. This is called as banking angle or angle of banking. Now, when the car is like this, when the car is coming towards us, okay, when the car, see, don't imagine this like a block because I cannot draw something to show you here because I can't use 3D. Imagine that this car is coming towards you, means you place it on a paper, the car is coming towards you. It is not going down the inclined plane. It is not like this. It is not like this. Okay, it is coming towards you. When this is happening, tell me what are all the forces that will act. Again, normal, mg, this will be n cos theta, and this will be, sorry, this will be n cos theta, and this will be n
and sine
sin
theta.
Yeah, right. This is without friction. If the friction was acting, then the friction would have acted along the inclined plane. Correct? So if I draw a dotted line here, Fs, then if this is theta, this will be 90 minus theta, then this would have been theta. Now see, if this is Fs and if this is theta, then Fs can be resolved into two components. What are they? Fs cos theta,
Cos theta,
and
Fs sine theta.
so this is one of the forces. Secondly, this is normal force. If this is taken as theta, then this will be n sine theta and this will be n cos theta. Accepted? Right. And this is the direction of center or direction towards center. Tell me what are all the forces that are acting in the vertical direction. Combine both the diagrams. Tell me what are all the forces that are acting in the vertical direction. N cos theta is acting upwards.
Yes, sir.
Yes,
So
sir.
n cos theta is balanced by the sum of the downward forces. How many forces are there in the downward
Two
direction?
forces.
2
What are they?
Fs sine
Fs
theta
sine
and
theta.
mg.
Very good. So Fs sine theta plus mg. Can I call it equation number 1? Similarly, what are all the horizontal forces acting which is giving rise to the centripetal force? N sine theta plus
Fs cos theta.
should be equal to, what is the only formula for centripetal force?
mv square by r.
E square by r. That's right. So this is what happens when there is friction along with banking. This is the concept given in your textbook. I just checked whether it is in the deleted portion. No, it is not. So you have this, okay? So n cos theta, can I write it as Fs is equal to, can I write it as mu s into n into sine theta plus mg. So if you collect all the n terms, it is cos theta minus mu s. Can I call it as equation number 3? Did you guys understand what I did? I collected the n terms on the left hand side. I equated it to the remaining terms on the right hand side. So n will be equal to mg divided by cos theta minus mu s sin theta. Right? So this is from 1. Similarly, n sin theta plus mu s into n into cos theta is equal to mv square divided by r. This is from second equation. So what should you do? You should take out n common again. Sin theta plus mu s cos theta is equal to mv square by r. So from this, what can we say n is? So if I take this as equation number 4, third equation is equal to fourth equation, which implies third equation is equal to fourth equation implies mg divided by cos theta minus mu s sin theta is equal to mv square by r into sin theta plus mu s cos theta. M and m will get cancelled. V square is equal to r into g into sin theta plus mu s cos theta, the whole divided by cos theta minus mu s sin theta. Tell me if there is any doubt till this step. You can copy it till this step. I guys there?
Yes.
Yes, sir.
Okay.
So they'll ask derivation in exams, sir.
This is for sure. There is a very important derivation. That is why I'm trying to explain how much ever possible. See, unfortunate thing is I have to show this and explain. This animation and all will not work, but for the time being, work on it. Once things are set right now, I'll repeat this topic.
Can you go off, sir? Sir, from yes, sir.
Find the
Sir, from n cos theta.
n cos theta here.
Yes, sir. Thanks, sir.
Yeah. Please write it down. There is a 3-mark derivation. Every time it gets repeated. It's not only for that, even for the competitive exams, there is a very important concept. Questions come from this.
You have to explain even using the diagram, sir.
No. In which? In
This
CBSE.
derivation.
Yes. See, every derivation should definitely have a diagram. Any derivation without a diagram is definitely wrong.
Okay, sir.
Can I go a little bit down, sir?
Then is this fine?
Yes, sir.
See, the derivation is not at all. There are two more steps. Let me know once you're done.
Yes, sir.
Okay. So V square is equal to Rg into sine theta plus mu s cos theta. Divide numerator and denominator with cos theta. Then what will happen is V square will be equal to Rg into tan theta plus mu s divided by 1 minus mu s tan theta. Because sin theta by cos theta is tan. Cos theta by cos theta gets cancelled. Again, cos theta by cos theta gets cancelled. Sin by cos is tan. So V will be equal to square root of Rg into mu s plus tan theta divided by 1 minus mu s tan theta. So this is the safe velocity with which a car can take a turn on what kind of a road?
Bank.
Banked
Bank
road?
road.
Is that all? Banked road? There is something else you need to fill with.
With friction.
With friction. That's right. Very good. Banked road with friction. If it is without friction, it is root of Rg tan theta. So you need to be very careful. If it is a leveled road, then it is only mu Rg. That also we saw yesterday. Right, sir? Okay. Sorry, I didn't get you. Your voice was
This
breaking.
is the minimum velocity for
Maximum.
car to
Less
turn
than
safely. So if it's greater, it will be a problem, sir.
See, mathematically, if I say A is greater than or equal to 2, then 2 is the minimum value. If I say A is less than or equal to 2, then 2 is the maximum value. Because when you write it, how you write 2 to infinity, here you will write it as minus infinity to 2. So what is the maximum value? The one which is on the right hand side.
Yes, sir.
Okay. I hope
Sir,
this is the
here
one
mu
you
s is computing value, sir, or the coefficient of some force.
Which one? Which one?
Mu s, sir.
Mu is the coefficient of static friction.
Oh, no, sir. I wrote it as limiting value, sir.
No. It is mu s is the coefficient of friction.
Okay, sir.
Okay. See, look at the use of this reaction, use of this relation. Okay. I'm bringing certain cases. Case 1, if on a banked road, friction is 0. If the friction is 0, then what will be the value of mu s?
0.
It is 0. So if I call this equation as 5, using mu s is equal to 0 in 5 will give us what? Root of Rg into tan theta divided by 1 minus 0. So that will give us root of Rg tan theta. I did it mathematically. Am I right or wrong? So V is equal to root of Rg tan theta. But what is the expression that we derived for banking of road without friction? Are you able to understand? So without friction,
Yes,
it is root of Rg tan theta. You can derive it from the expression which you have derived using friction also. So in that value, you need to substitute mu s is equal to 0. So case 2 is no banking, but friction present. So what scenario is this? No banking means it's a leveled road. On a leveled road with friction, what will happen? So no banking means what will be 0? Theta is equal to 0. Using in 5, what do we get? V will be equal to root of Rg into mu s plus tan 0 divided by 1 plus mu s into tan 0. 1 minus, right? Are you guys able to understand this point? What is tan 0? Tan 0 will be 0. Mu s into tan 0 is also 0. So you will be left out with mu s into Rg. What is this thing? Did we see this?
Yes, sir.
So that was the first derivation which we saw yesterday, right? Where is it? V is equal to root of mu s into Rg. So you're able to understand? So this is a special case. Banking of road with friction can be treated as a special case from which the remaining expressions can be derived. Okay. So this is all about.
Sir, can you know what is G, sir?
What is?
What is small g, sir?
All these acceleration due to gravity.
Okay, sir.
Coefficient of static friction. R, radius of circular track. G, acceleration due to gravity. Theta, angle of banking. Okay. So these are all the values, guys. Did you understand?
I have a doubt.
Yeah, tell me.
If they ask us to derive this formula for on a level road, mu rg formula, sir,
Yeah.
can we just directly derive it from the banking of
Yeah,
road
yeah, you
formula?
can directly derive it. No, don't go. You mean to say you will directly take this and do it.
Yes, sir, since you would already
No.
know that.
Don't do that because that's not there in textbook. All these things I'm explaining.
Okay.
These cases are not there in the textbook. I'm explaining so that you can relate and study. That is my objective. When they ask for a leveled road, do the derivation which I showed you for the leveled road. They ask you for banking of road without friction, exactly the same derivation. Don't do these cases and all.
Okay, sir.
Okay. See, conceptually it is right, but it will not be accepted in schools. Okay. So just go with the NCERT part, you will get the marks. That's it. Okay. So we are done with this chapter. So this concept actually unexpectedly took so much of time. I never take this much of time for this, but unfortunate thing is I'm not able to show you the right demonstration. So is there any other doubt from this chapter? Is there any other concept or something which you couldn't understand?
Sir, for every problem, should we draw a free body diagram?
If it is related to that, yes, you need to. Free body diagram is the life of physics. I'm not saying it is the life of this chapter. Okay. So have that in mind because if you want to break down a system and analyze, free body diagram is the best thing. I'm not going to stop it here alone. I'll be using throughout physics. Okay. So even if it is not required, I suggest you to draw. I cannot say which question requires, which will not require. I'll suggest you to observe everything with the free body diagram so that you have better clarity on it. I hope it is clear. Sashmit?
Yes, sir.
Is it clear?
Yes, sir.
Yes.
Yes.
Good. Yeah. Any other doubt, guys? Any other conceptual doubt? Angle of repose, friction, limiting friction, kinetic friction. So what is friction? What is mechanical equilibrium? Conservation of linear momentum. Have this in your mind, okay? In this chapter, we'll use this conservation of linear momentum. And yes, definitely free body diagrams you need to practice. Then
Sir, a doubt, sir.
tell me.
Sir,
Tell me.
a doubt, sir.
Tell me.
Sir, what is the what is the factor on which the coefficient of friction depends, sir? Can you see the factor on which the coefficient of friction depends?
The factor depends on the roughness of the surface only. And why is the surface having roughness in it? It is because of the irregularities. Okay, depending on how much irregular the surface is, it depends the coefficient of friction. Okay, I cannot say that this is the case. For example, if you ask me, right, I will say the coefficient of friction on an inclined surface depends on the angle of repose. Okay,
Okay, sir.
I can say it depends on the angle of friction, but those are all slightly different concepts. Okay, most of the cases it depends only on the irregularity that is present in the surface.
Okay, sir.
Okay. By the way, this information is not needed, but you can, for your knowledge, I'm just saying the branch where friction is studied is called as tribology. So it's actually a tough concept. Tribology is a branch of physics which deals only with friction. Just for your knowledge. Okay. So I hope this chapter is clear. Yes.
Yes, sir.
Okay. So two updates. Okay. Two updates. One is your previous test papers. I'm correcting it. Okay. So you can expect it maximum by Saturday. By Saturday, I'll try to give it off. I'm little occupied with some other work and other classes also. So I'll try to give it by Saturday because it's a 70-mark paper. It is taking so much of time. Secondly, I will give assignments in this chapter. So assignments in this chapter will be mainly based on the concepts which involves free body diagram and conservation of linear momentum. So I want you to try these two things because they have connectivity and importance in the other chapters also. And the third important announcement is I will conduct a test in this chapter in the next Sunday. Okay. What is the date? So this Sunday, what is the date?
20th, sir.
Sorry, I didn't get you. 28th.
2020, sir.
20th. Okay.
Yes, sir.
20th, you will have a test. I'll try to keep it simple. Let's do it for 25 marks. Okay. And you will have a 1 hour test between 10 to 11 a.m. So make sure you practice and get your doubts cleared before 20th. You have solid 10 days time. Prepare well.
So
Any
only
help
this
needed?
chapter,
Only this chapter. Only this.
sir? Okay, sir.
Okay.
And,
Secondly,
last
any
test,
help? Last test?
sir, last test you asked one graph question, sir, but I was not having graphs, sir. So I drew it roughly, sir.
Rough is fine. Rough is fine. That's fine. That
Sir,
I take it.
graph, no, sir. Should I use that graph book, sir, for the graph questions?
No need. No need. Physics, we don't use it. You will generally draw a rough graph.
Then okay, sir. Okay, sir.
It is in math only. See, math also you use it only for linear inequalities. Nowhere else you use graph sheet. Everywhere else is a rough graph.
Okay, sir.
Okay. Yeah. So
For this
that is all.
test on the
Sorry, I didn't get you. Chapter
and
name, right?
on the test for 20th, it contains the whole lesson.
Yeah, whole lesson. I'll give a crisp version of this chapter's question paper. Okay, I'll give it only for 25 marks. Let's have it for 1 hour.
Okay, sir.
Okay. I'll try to focus only on the important points, so that even I can correct fast and give the papers. The 70 marks is taking so much of time for me. I don't want to delay that. That is why. Okay. So that's it with respect to this chapter. So next class I will start work, energy and power. See, going forward I'll go a little fast because I've created all the basics that are needed for the remaining part of your physics. Now it is your work to sit and practice all these free body diagrams or how to resolve the components. I think I've given enough practice on that. Going forward, I'll not tell you, I'll not ask anything, I'll just draw and go off. It's your work to revise everything. Okay. I don't want to waste time on explaining each and everything again and again. So next class, I will be starting work, energy and power. Ensure you have all the basics right. Especially you need to be good with vectors and this chapter for you to understand. So I'm telling you again, you need to revise. You need to revise vectors and this chapter, FBD, free body diagram, and what? Conservation of linear momentum. These two have to be practiced. If any doubt you have, ensure you get it cleared. Okay. So if you have a doubt, you can message. I will try to respond back within 24 hours. Is that clear? You can message me personally. You have the other number, right? Personally, you can message me. I'm trying to get a new number for separate doubts clearing session itself. I'll give you an update regarding that on Monday. But in the meanwhile, if you have any doubts, you can personally ping. I will respond back either with a voice note or I will try to solve and send however it is comfortable. Is that clear?
Okay, sir.
Okay. Okay. So that's it, guys. That's all for today. Next class, we'll start with work, energy, power.
Thank you, sir.
Yeah.